Okay, so what if we have the integral of 18 e to the 3x times the square root of 6 plus e to the 3x with respect to x? Okay.
So just 3x, each of 3x?
Yes, e to the 3x. Both of those are e to the 3x. Okay, so with this one, our goal isn't to make it e to the u du, because we have too much going on there to convert it to that. But instead, this square root lets us know that we're going to make it into u to the 1/2 power. Okay, so from there.
But wouldn't that be a smaller exponent? Because it'd be a half, and the other one would be like a 1.
What do you mean a smaller exponent?
You know how you have like, I don't know, confuse myself here.
Oh, you mean like we did for the sine and the cosine? Yeah. Oh yeah, you really only have to do that with the trig ones.
Only with trig?
Yeah, with the trig one, that's the main ones.
Okay.
With these, you don't have to worry about it as much, because it's very rare that you'll find like e to the 8x or something like that, because it's a whole different approach to simplifying those. All right, so with this one, we're going to let u equal 6 plus e to the 3x. Okay, so our derivative of u is going to equal derivative of 6, that just disappears. So we're going to have the derivative of e to the 3x with respect to x. Okay, so derivative of e to the 3x, remember that's e to the u times the derivative of that, or e to the gx times g prime of x.
B3.
Yep, so this, yep, 3e to the 3x with respect to x. And divide both sides by 3, or du over 3 equals e to the 3x dx. Now, if you wanted to, like I said, and sometimes it can get a little bit tricky, you can make that 18 into 6 times 3, factor the 6 out, and just move the 3 next to it. You could have done it that way. But sometimes that works, and sometimes it doesn't. And the reason I like this is because you can do it this way over and over, no matter what numbers you have. So I like to find something that works and stick to it. Instead of saying, okay, for this one I'll do this method, and this one I'll do that method, and that one I'll do this method. Find one umbrella method. It usually works.
So this would be technically the square root of u to the times du to the 3rd.
Not our, yep, though, yeah, du divided by 3.
Yeah, once
Yep.
you bring it out, it'll be 6 technically.
Yep, it would still be the 6. So the same way we could have just made it 6 times 3, and it would have been 6, it'd still work out to be just 6. It just kind of went the different route. Okay, so we have 18 times the square. So instead of the square root, I'll just make it 6. Yep, 6 plus e to the 3x to the 1/2. Let me clean that up a little bit.
Is it easier just to make it to the 1/2?
Only because when we turn it to u, we're going to end up with the square root of u, and we're going to turn that to u to the 1/2. So it just kind of jumped ahead a little bit.
You have to bring it out.
Exactly. All right, so our e to the 3x dx, okay, that gives us our du over 3. And that gives us our u to the 1/2 power. Okay, so you have 18 times the integral of u to the 1/2 power times du over 3, where we can bring our 3 right on out. So 18 over 3 times the integral of u to the 1/2 du. Okay, so that gives us 6. and u to the 1/2, that becomes u to the 1/2 plus 1 is 3 over 2 over 3 over 2 plus c, since it's an indefinite integral. Okay, so we multiply the numerator and denominator by 2 over 3. You get 6 times 2 over 3, u to the 3 over 2 plus c. We get 12 divided by 3, which is 4. So that becomes 4 u to the 3 over 2 plus c. And all we have to do now is replace the u. Okay, so that is 4 times 6 plus e to the 3x to the 3/2 power plus c. All right, so any questions on that one? All right. So we'll do one more with e. And we'll move up to the log intervals. Okay, so the integral from -1 to 0 to e to the 3t plus 6 with respect to t. Okay. Now this one, pretty straightforward. You don't have a whole lot going on. So you can just let u equals 3t plus 6. So we can get our e to the u. Okay, so your derivative of u is equal to 3 with respect to t, or du over 3 equals dt. Okay, so if we rewrite it, just bring our 2 right on out. So the 2 from -1 to 0, e to the 3t plus 6 with respect to t. That gives us our e to the u, and that gives us our du over 3. Oops, we got my 2. From -1 to 0, e to the u times 1/3 du. Bring that 3 right out. So from -1 to 0 of e to the u du. So the integral of e to the u is just e to the u. So you have 2/3 times e to the u from -1 to 0. Once again, we have to replace u before we substitute. Okay, so that gives us 2/3 times e to the 3t plus 6 from -1 to 0. Okay, so we have our 2/3. If we plug in 0, we have e to the 3 times 0 plus 6 minus, we plug in our -1, e to the 3 times -1 plus 6. Which gives us 2/3 times e to the 6th minus -3 plus 6 e to the 3rd. All right. So any questions on that one? All right. Okay, looks like everyone's done writing. Okay, so what if we have the integral of 11